Hello, in this lecture we will find the radius of a circle enclosed in a triangle. We have in the picture triangle ABC. Side AB of the triangle equals to 4 units, side BC equals to 3 units, and the side AC of the triangle equals to 5 units. And inside the triangle we have a circle, and we want to find out the radius of this circle. First of all, let's define the center of this circle as O. Point O is the center of this circle, and actually the touching point between side AB of the triangle and the circle will be called N. Again, N is the touching point between side AB of the triangle and the circle. Or we can also say that the side AB is tangent to the circle at point N, and we will also define the touching point of side BC of the triangle with the circle as point M. Again, point M is the touching point between side BC of the triangle and the circle. Or we can also say that side BC of the triangle is tangent to the circle at point M. And we will also define the touching point between side AC of the triangle and the circle as P. Again, point P is the touching point between side AC of the triangle and the circle. We can also say that side AC of the triangle is tangent to the circle at point P. Okay. In the next step, we will connect together by a straight line points N and O. Actually, line segment NO is the radius of this circle because of the fact that it starts from the center of the circle, that is to say point O, and ends at point N, that is a point on the circle itself. For that reason, line segment NO is the radius of this circle. I will mark it as a small r. In the same way, we will connect together points O and M by a straight line. And line segment MO is also the radius of this circle. I will mark it as R, small r, because of the fact that line segment MO starts from the center of the circle and ends at point M, that is a point on the circle itself, it is defined as the radius of this circle, and we will also connect together by a straight line points O and P. Line segment OP is the radius of this circle. I will mark it a small r. Again, because it starts from the center of the circle, from point O, and ends at point P, that is a point on the circle itself. Okay, so actually the definition of a radius of any circle is any line segment in the circle itself that starts from the center of the circle and ends at any point on the circle itself. It is defined as the radius of the circle. And actually those three line segments, line segment NO, line segment OP, and line segment MO in the circle, satisfy the definition of a radius of a circle. For that reason, those three line segments are the radiuses of this circle. Okay. In the next step, we actually have a rule. I will call it rule number 1. Actually, rule number 1 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. I will read rule number 1 again. Rule number 1 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So actually, if we have a radius, let's call it R, and we have tangent to that radius, let's call it T, then the radius is perpendicular to its tangent T. That is to say, this angle is 90 degrees and this angle is also 90 degrees. So in any circle, the radius is perpendicular to its tangent. Okay, so we actually can implement rule number 1 in our circle, because we have, for example, line segment NO is the radius of this circle, and we have tangent to the radius. Side AB of the triangle is tangent to this radius. For that reason, according to rule number 1, the radius is perpendicular to its tangent AB, that is to say, angle ONA equals to 90 degrees, and also angle ONB equals to 90 degrees. Okay, and in the same way, line segment MO, that is the radius of this circle, has its tangent side BC is tangent to this radius. For that reason, according to rule number 1, angle OMB equals to 90 degrees, and also angle OMC equals to 90 degrees. Okay, and also line segment OP is the radius of this circle, and we have the tangent to this radius, that is side AC of the triangle is tangent to this radius. For that reason, according to rule number 1, angle OPA equals to 90 degrees, and also angle OPC equals to 90 degrees, because the radius OP is perpendicular to its tangent AC. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay? We have actually the formula for any triangle is the formula for the area of any triangle equals to the base of the triangle times the height to the base divided by 2. Okay, so the formula for the area of any triangle actually is the equals to the base of the triangle times the height to the base divided by 2. And actually the height to the base must create 90 degrees with the base. And instead of area of triangle, we can use the capital letter A, abbreviation for area. So we can say that A equals to the base of the triangle times the height to the base divided by 2. Okay, A, that is the area of triangle. A is the abbreviation for area. So the area of a triangle equals to the base times the height to the base divided by 2. Again, I will emphasize the fact that the height of a triangle must create 90 degrees with its base. Okay, actually we can implement this rule in order to find out the areas of the triangles that inside the big triangle. From first of all, we will connect together points B and O by a straight line. We'll connect together points O and C by a straight line. And we'll connect together by a straight line points A and O. Okay, then we will calculate the area of the green triangle according to the formula that I present to you 2 minutes ago. So the area of the green triangle BOC will be equal to the base of the triangle. The base is given us as 3 units. So it is 3 times the height to the base. As I've already told you, the height must create 90 degrees with the base. So the height of the green triangle is the radius, because the radius creates 90 degrees with the base. Angle OMC equals to 90 degrees, and also angle OMB equals to 90 degrees. So the height of the green triangle is the radius of the circle. So it is the base, that is 3 units, times the height, that is the radius, divided by 2. Okay? So the area of the green triangle equals to the base of the triangle, that is actually 3 units, times the height. The height must create 90 degrees with the base, so the height of the green triangle is the radius. So it is 3 times the radius over 2. Okay? 3 over 2 is 1.5. I will write it down. So the area of the green triangle equals to 1.5 times the radius. Okay? And in the same way, we can use the formula for the area of a triangle in order to find out the area of the yellow triangle. Okay, the area of the yellow triangle AOC equals to the base of the triangle. The base is given us in the question. It is equal to 5 units. So it is 5 times the height of the yellow triangle. The height must create 90 degrees with the base. As you can see in the drawing, the radius creates 90 degrees with the base, AC. Angle OPA equals to 90 degrees and angle OPC equals to 90 degrees. So the height of the yellow triangle equals to the radius of the circle, all divided by 2. So the area of the yellow triangle equals to the base of the triangle, that is 5 units, times the height. The height of the yellow triangle is the radius, all divided by 2. 5 over 2 equals to 2.5, so I will write it down. So actually the area of the yellow triangle equals to 2.5 times the radius. Okay? And in the same way, we can calculate the area of the orange triangle. The area of the orange triangle, triangle AOB, will be equal to the base of the triangle. The base of the orange triangle is 4 units, it is given us in the question, times the height to the base. The height must create 90 degrees with the base AB, so the radius creates 90 degrees with the base AB, so the height of the orange triangle is the radius of the circle, so it is 4 times the radius divided by 2. So the area of the orange triangle equals to the base of the triangle times the height, that is the radius of the circle, divided by 2. Okay, 3 over 2 equals to 2, so I will write it down. So the area of the orange triangle equals to 2 times the radius of the circle. In total, we can say that the area of the green triangle equals to 2.5 radius, 2.5 times the radius of the circle. The area of the green triangle equals to 2.5 times the radius of the circle. The area of the yellow triangle, this yellow triangle, equals to 2.5 times the radius of the circle, and the area of the orange triangle equals to 2 times the radius of the circle. Okay? And actually the area of the big triangle ABC the area of the big triangle ABC equals to the sum of the areas of the yellow triangle plus the area of the green triangle plus the area of the orange triangle. Okay, so we actually can write down equation number 1, that the area of the big triangle ABC equals to the sum of the areas of the green triangle, that is actually 1.5 times the radius, plus the area of the yellow triangle, that is 2.5 times the radius of the circle, plus the area of the orange triangle, that equals to 2 times the radius of the circle. Okay, so in total, we can say that the area of the big triangle ABC equals to the sum of the areas of the green triangle plus the area of the yellow triangle plus the area of the orange triangle. Or the area of triangle ABC equals to the area of the green triangle plus the area of the yellow triangle plus the area of the orange triangle. Okay, and we actually can summarize this side of the equation. 1.5 times the radius plus 2.5 times the radius equals to 4 times the radius, and 4 times the radius plus 2 times the radius equals to 6 times the radius. So the sum of this side of the equation equals to 6 times the radius. I will write it down. So the area of the big triangle ABC equals to 6 times the radius, because the sum of this side of the equation equals to 6 times the radius. Okay, the area of triangle ABC, the big triangle, equals to 6 times the radius of the circle. But we have already know from the question that the area of triangle ABC equals to 6 times the to 6 units. The area of triangle ABC is given us in the question. The area of triangle ABC equals to 6 units squared. So we actually can substitute the area of triangle ABC by 6. Okay. So we substituted the area of triangle ABC by 6. We got that 6 equals to 6 times the radius. We can divide the equation number 1 by 6. We'll get that the radius of the circle equals to 1 unit. Okay, so the answer to the question is that the radius of this circle that enclosed the triangle ABC equals to 1 unit. Okay, so now I will summarize the lecture. We actually wanted to find out the radius of the circle enclosed in triangle ABC, and we know that the side AB of the triangle ABC equals to 4 units, side BC of triangle ABC equals to 3 units, and side AC of the triangle equals to 5 units. And we know that the area of triangle ABC equals to 6 units squared. And inside the triangle we have a circle, and we want to know the radius of this circle. First of all, we defined the center of the circle as point O, and then we defined the touching point between side AB of the triangle and the circle as point N. We can also say that the side AB of the triangle is tangent to the circle at point N, and we define the touching point of side BC with the circle as point M, and we also define the touching point of side AC of the triangle with the circle as point P. We can also say that the AC is tangent to the circle at point P. BC, side BC of the triangle, is tangent to the circle at point M, and side AB of the triangle is tangent to the circle at point N. Then we connect it together by a straight line points N and O, and we also connect it together by a straight line points M and O, and we connect it together also points O and P by a straight line. So we created 3 line segments: line segment NO, line segment MO, and line segment PO. Actually, those 3 line segments are the radiuses of this circle, because they start from the center of the circle, that is to say from point O, and ends at any point on the circle itself. For that reason, they are the radiuses of this circle. According to the definition of the radius of any circle starts from any line segments in the circle itself that starts from the center of the circle and ends at any point on the circle itself. It is defined as a radius of a circle, and those 3 line segments satisfy the definition of a radius of a circle. For that reason, they are the radiuses of this circle. Okay, and then we actually have rule number 1 that states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So actually, if we have radius R and tangent T, then to the radius, then this angle equals to 90 degrees, and also this angle equals to 90 degrees. So in any circle, a radius and the tangent to that radius are perpendicular to each other. So we actually can implement rule number 1 in our circle, because we have in our circle 3 radiuses and 3 tangents to those radiuses. So according to rule number 1, the radiuses are perpendicular to their tangent. That is to say, line segment NO, that is the radius of this circle, as the tangent AB. Side AB of the triangle is tangent to this radius. For that reason, according to rule number 1, angle ONA equals to 90 degrees, and angle ONB equals to 90 degrees, because the radius is perpendicular to its tangent AB. And also line segment MO, that is the radius of this circle, as its tangent BC. BC is tangent to this radius. For that reason, the radius is perpendicular to the tangent, that is to say angle OMC equals to 90 degrees, and also angle OMB equals to 90 degrees. Okay, and also we have line segment OP, that is the radius of this circle, and we have the tangent to this radius, that is side AC of the triangle, and according to rule number 1, the radius is perpendicular to its tangent OC, that is to say angle OPA equals to 90 degrees, and also angle OPC equals to 90 degrees. Because the radius is perpendicular to its tangent, that is to say this angle is 90 degrees and this angle is 90 degrees. Okay, and we actually have the general formula for the area of any triangle. The area of any triangle equals to the base of the triangle times the height to the base divided by 2. or instead the area of a triangle, we can use the capital letter A, that is abbreviation for area. So A, the area of the triangle, equals to the base times the height to the base divided by 2. And the height to the base must create 90 degrees with the base itself. Okay, so we can implement this rule in order to find out the areas of the triangles that are inside the big triangle ABC. We actually connected the points O and B by a straight line. We also connected points O and C by a straight line, and we also connected points O and A by a straight line. And then we calculated the area of the green triangle. The area of the green triangle actually equals to the base of the triangle. That is actually 3 units. It is given us in the question. The base times the height to the base. The height must create 90 degrees with the base, and the height of the green triangle is actually the radius of the circle, because the radius of this circle creates 90 degrees with the base BC, because angle OMC equals to 90 degrees, and also angle OMB equals to 90 degrees. So in total, we can say that the area of the green triangle equals to the base of the triangle, that is 3 units, times the height, that is the radius, divided by 2. Okay, so the area of the green triangle equals to 3 over 2 times the radius of the circle. 3 over 2 is 1.5, so the area of the green triangle equals to 1.5 times the radius of the circle. And in the same way, we calculated the area of the yellow triangle. The area of the yellow triangle equals to the base of the triangle, that is 5 units, times the height to the base. The height must create 90 degrees with the base, so the height is the radius, because the radius creates 90 degrees with the base AC. So the area of the yellow triangle equals to the base, that is 5 units, times the height, that is the radius, divided by 2. Or 5 times the radius divided by 2. 5 over 2 equals to 2.5. So in total we can say that the area of the yellow triangle equals to 2.5 times the radius of the circle. And in the same way we calculated the area of the orange triangle. The area of the orange triangle equals to the base of the triangle, that is 4 units, times the height to the base, that is the radius of the circle, divided by 2. So in total the area of the orange triangle equals to the base, that is 4 units, times the height, that is the radius, divided by 2. 4 over 2 is 2, so in total the area of the orange triangle equals to 2 times the radius. So we actually calculated the area of the green triangle and the area of the yellow triangle, and we calculated also the area of the orange triangle, and we also know that the sum of the areas of those 3 triangles equals to the area of the big triangle, triangle ABC. Okay, so we created equation number 1 that states that the area of the big triangle ABC equals to the sum of the areas of the green triangle plus the area of the yellow triangle plus the area of the orange triangle. Okay, so the area of triangle ABC in total equals to 6 times the radius, because the sum of this side of the equation equals to 6 times the radius of the circle. Okay, so the area of triangle ABC equals to 6 times the radius of the circle, but we know that the area of triangle ABC equals to 6 units squared, so we can substitute the area of triangle ABC by 6, and we will get that 6 equals to 6 times the radius of the circle, and we divided equation number 1 by 6, and we got that the radius of the circle equals to 1 unit. Okay, so the radius of the circle enclosed in triangle ABC equals to 1 unit. Okay, thank you very much.